So in today's video, we're going to be doing an absolute beginner guide into choosing an ESC. Now we're going to be talking about the ESC itself. If you've missed the flight controller one, I'll have it linked down below. Now by the end of this video, I promise you'll be able to choose an ESC like a professional would or a veteran flyer. So there are a couple things we need to discuss here before we jump into real world examples where we actually browse the web and take a look at specifications, take a look at pictures, because the pictures play a big role. Don't only look at the numbers, the pictures are as well very important here. So with that being said, the timestamps will be down below, also shown in the video progress bar, and also some of my ESC recommendations will be linked down below along with the flight controller recommendations if you want to go ahead and jump there and start looking around. And one more thing, why don't you come pick up some of my merch? It's in the links down below. Go check it out. You might like a couple things there. We do all of them in-house by hand. We design, cut, and heat press them right on the t-shirts, and I got good quality t-shirts. As you can tell, I've been wearing my own t-shirts for ever now, and they're just awesome quality. So let's get started. So in the market, there's two types of ESCs. We have BL-Heli-S and BL-Heli32. Now the main differences comes down to the processing power and also the features it provides. However, BL-Heli32 is theoretically better, but at the same time, you're not going to gain much more performance than a BL-Heli-S. Sometimes actually BL-Heli-S would outperform a BL-Heli32. So just putting that out there, you know, don't really concentrate too hard on BL-Heli32 and BL-Heli-S. Whatever fits your budget and whatever you think is good for you, just go ahead and grab it. So let's go ahead and start with the most important thing here. Now, size. Size is the top priority here because, for example, if you got a frame that fits 20 by 20 or micro ESCs, then you're not going to be able to buy 30 by 30. So that's the first thing you always want to make sure. What size is your frame, or what size stacking solution does your frame accommodate? And again, we'll look at those examples in the later steps. So there are a couple sizes actually in the market that we're just going to cover the basic ones for like a 5-inch quadcopter. So we have 20 by 20 ESCs as well as flight controllers, and we have 30.5 by 30.5, which everybody calls 30 by 30s. So those are the two types of ESCs we have. We actually have a couple more, but that's if you're building something like a super tiny micro or something. But most of the time it's going to be the 30 by 30s and 20 by 20s here. Now this also is 30.5 by 30.5, but just to make it a little bit simpler, it's 30 by 30. So that's the first thing you always want to take a look at. So once you know what size your frame could actually accommodate, then we can go ahead and move on to the next step. So the M size, what does the M size stand for here? Well, the M size is the Mosfet size. Now these are the little chips, which I'll show you in a little bit, that are in charge of the power delivery down to your motor. There's other things also, but that is one of the main things. That's the thing right before your motor gets the power. The bigger the better, because you know the thing you always want to look for is power delivery and also heat dissipation, because once they get hotter you get less power output, or less power output to the motors, and you also want these to be as cool as possible and also be able to dissipate heat as much as possible, and also in a crash be able to handle such a really nasty voltage spike or inrush of current, because when the motor is turning, all the current inside of it, this is the simplest way I could figure to explain it to you guys, all of the current is inside the motor. Now if a propeller hits a tree and it stops, that the collapse of the magnetic field will allow just all that current to pipe back through into the ESC. And if you don't have big enough FETs, you'll tend to fry them. I don't know if you guys, I don't know how new you guys are, but if you remember the old toothpicks that we had, they had super tiny FETs. And usually if you had air mode on and you crashed and the thing just went crazy, it'll burn the FET, and that's what usually happens because the FET wouldn't be able to handle such thing. That's why Mosfet size is really important, especially if you're doing a high load setup, for example, or a high load application setup like a racing quadcopter, or a high KV setup like 2700 KV with some 5.1 inch props and super crazy pitch. So if you're building a high load application quadcopter, the Mosfet size does play a big role, and always keep that in mind. Now, if you're building something like a 2300 KV, you're going to be fine with any FET. Even up to 2400, but once you start going to the 2207, 2750 kV, you're going to need to look at the FETs and keep a close eye, and I always highly recommend a bigger board for that, because the heat dissipation will also be much better most of the time. So the next down on the list is the input voltage. The input voltage, again, is very important because you have to know if you're going to be building a 4S setup or a 6S setup. It's very important you know that, because that also dictates your motors and dictates your flight controller, also dictates your ESC's input. It's very important you know this stuff. So most of the ESCs nowadays are 4 to 6S ESCs, which means basically 18 or 16.8 to 25 volt input. Now, the 25 volt input, you got to take something into consideration here, and the 16.8, which is the 4S. Now, in a perfect world, the voltage will stay at 16.8, and as the battery drains, it goes down, 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 down. But that's not a perfect world. What happens is, as the motors are spinning up and down, stopping and everything, you'll actually see the voltage, even though the battery is 16.8. With really bad ESCs, you get something called noise, which will actually allow the voltage to go up to like 25 volts or even 30 volts, which is crazy. And that's where the next factor comes into play, which we'll cover in a bit here. So it's always good to get a 4 to 6S ESC. Always keep that in mind. Just take a look at their 4 to 6S ESC. That'll allow it to handle these nasty voltage spikes if any were to arise somehow. So, but most ESCs are 4 to 6S anyways, but just always look at that, just in case. Some ESCs will say only 4S only, because there's still some older ones in the market, and you just want to make sure that you get one of the latest ones that can actually handle this much input power, because also the design is slightly different than a 4S version. So the next is filtering. Actually, this is one of the most important things on an ESC, but obviously the first three are the ones you need to know before you actually continue. Filter, filter, filter. Filtration is really important, and it's those little capacitors, which again I'll show you an example a little bit later. The more you have, theoretically, the better you're off. And what that does is, remember how I told you about the voltage spikes? Because we're mixing an AC circuit with a DC circuit, and it's just these don't coexist very well. And what happens when the motors are spinning and stopping and everything, the voltage and the current also is fluctuating just rapidly, constantly. It's never stable. And if you don't have good filtration, then that voltage spikes and everything could jump into your video transmitter, into your flight controller, into your gyro, and create all kinds of problems that you won't be able to fix unless you add a fat low ESR capacitor. But it's always good to have an ESC with good filtration on board, because what that does is it soaks up those voltage spikes and those voltage drops as well. Voltage drops are also very dangerous. Back then, we used to have blackouts. Nowadays, we don't have blackouts anymore. It was, for example, you're running a 4S battery and you punched out, and the filtration wasn't so good and the battery wasn't as decent as they are now, and the voltage of the battery would dip below 7 volts, turn off your video transmitter. I used to run into these problems. A lot of people used to run into these problems, especially when you did a quick roll, boom, the voltage drops, you get a blackout. It's insane. Sometimes it'll even reboot in the air. So filtration is very important. The amount of capacitors on board is very important. It's always good to have something with at least some filtration, and also always add that low ESR capacitor, which we're going to cover later. So we're just going to put the more, the better, always. The more, the better. And I've done a lot of tests on noise testing previously, and the reason why I stopped doing that is because it takes so much time. It just doesn't get any views. I just don't see why it's worth it anymore. I would love to. I love testing these stuff and putting numbers to ESCs. Now, the last thing is features. Now, the main features are going to be between BL Heli-S and BL Heli-32, and we rarely see that many features added, lately to ESCs, which we'll take a look at examples later on. Now, the main feature here for BL Heli-S is it runs D-Shot 600. That's the maximum for a BL Heli-S, and this one runs D-Shot 1200. Now, is there a difference? Yes, the D-Shot 1200 is faster, and D-Shot 600 is also fast. But we actually don't even need D-Shot 600 because we just, we were locked to 8K PID loop, so it doesn't even matter anymore. So that's not really something to look at unless later on somehow Betaflight goes back up to 32 kilohertz. That's when D-Shot 1200 will come into play. But also you'll get a lot more problems because everything becomes so more sensitive to vibrations and everything of that nature. So these aren't really a big, deal breaker or something you'd want. Now, one of the main features of BL Heli-32 when it first came out was it was able to give you, or it still can, give you your current for each motor. It gives you telemetry for each motor. But nowadays, they don't do that anymore. So it's basically like a BL Heli-S ESC. They don't add that extra functionality on the board itself. So, it's for me, I don't care if it's BL Heli-S or BL Heli-32 anymore. It's just, they're both basically identical in terms of features. Now, some of them might have a voltage regulator, but it's really rare nowadays. If it does, that's great. If it doesn't, that's also great, voltage regulator. We don't even need that anymore because now basically most of the latest flight controllers just take raw battery voltage, so we don't even need these regulators no more. Now, there are some nice ones that come with 10-volt regulator. Now, if it's a proper ESC that comes with 10-volt regulator, then that's a fucking beast. I can tell you that right now. That's something I'd want. I always love 9, 10-volt regulator, 8 to 10-volt regulator. I love them on anything, whether it's a flight controller or an ESC. I love them because remember how I told you about the noise going up and down? Well, when you feed your video transmitter through the 10-volt regulator, that noise doesn't go in there. So you're not getting those weird ass lines, those weird ass blackouts. Well, we don't have blackouts anymore, but you're not getting all these weird ass lines or anything in your video feed, which sometimes hinders it unflyable because you can't see jack shit. So 10-volt regulators are always plus, and depending on how much room it took on the ESC and what was sacrificed in order to do that. So you just have to find one with the right balance, and in the market currently, we really don't have that many. I think maybe like 2 or 3 ESCs that have 10-volt regulators. Other than that, we really don't need them anymore. So that's going to conclude it for the first part. So let's go ahead and take a look at examples and make sense of most of this information now. All right, so now we're going to go ahead and take a look at examples to understand this a bit more here. So first of all, we're going to start with a 20x20 ESC, which is this one right here. Now remember how I said I don't recommend 20x20 ESCs for high load setups. However, this is the only exception in my opinion because I've used it and it has some crazy FETs on board. If you could tell, those metal things that are on these black dots, these are the FETs right there, those top ones right there. And that's basically like an inbuilt heatsink for these FETs. And the filtration also looks really great. And this right here is the top of the line 20x20 ESC that you could possibly purchase. It even has the latest flight controllers, which is the F3s for these. This is the fastest microcontroller for ESCs right now. So this is the only kind of use case where I'd say, yeah, I'd probably use this on a high load 6S setup just fine, or a high load 4S setup just fine. But as you can tell, it is pretty expensive, but you do get what you pay for here. And I've tested this and I know how this works. Now, also, if we look down here, we see that it has a constant current 45 amps, peak current of 50 amps. You kind of take those in consideration. Usually they can handle that stuff, but never just really look at that number. And 3 to 6S input, no voltage regulator, as you can tell, and it has an output VBAT. So if you're ever going to connect this ESC with a flight controller, another 20x20, make sure the 20x20 flight controller can take battery voltage, which will say 4 to 6S input, or it will just say 6S input. Then you'll know it'll take up to 6S, and you're going to be totally fine in that perspective. Now, they also do provide you with another low ESR capacitor, which is highly recommended you add. And you add that usually on the back. You add it over here with the power rails. And I do a lot of these video tutorials on ESCs, how to set them up. So you can go ahead and check one of my older videos. So now let's take a look at another 20x20. This is a really good example here. So the price is very attractive, $32. What do you get? 2 to 4S. So it takes 2 to 4S. And it's 25 amp maximum. Now this is really nice of Diatone to tell you that it takes 25 amp, because probably some other company will say 35 amp, and you'll end up burning it on even a 4S 5-inch setup. So for example, an ESC of this nature, of this magnitude, would just be for some kind of a 3-inch quadcopter, you know, and anything below that. That's where I would put this on. I'm not saying you won't get away with it. I'm saying you will probably get away with putting it on some kind of a low load 4S setup, 5-inch. But you have a high probability of burning this ESC. Now, take a look at the price here. There are alternatives that are actually 30x30 and are actual beasts nowadays that are being released. So this is, we'll come back to this one later. This one's just insane. So here's another example. This is a 50 amp ESC from Diatone, just D-Shot 600, which means it's the BL S, 3 to 6S, 50 amps, fat heatsink, great filtration, and it's $41. I use this. I have this on one of my favorite quadcopters, and I could tell you that it's a really good one. Now, let's just take a closer look down here. It just says 50 amp maximum, constant, and 55 burst for a couple seconds. So if we scroll down here, what we can see, obviously we see the heatsink. We also see nice filtration. I like seeing that filtration right there. And overall, it's a really good one. You can see the FET size. Look how big they are. And if you don't know the sizes, usually all of them have this little chip that has this little sign. This is the 4-tier FET driver. And if the FETs are bigger than this one, then you have the big FETs and you're going to be good. This is the easiest way I could tell you right now. So this is a really good ESC right here, and I'd highly recommend. Now, there are also newer, cheaper variants. However, I haven't tested this personally yet, but this is from a well-known company, which is T-Motor. They've recently released a couple of these. This is their cheapest one, which is a 45 amp rated 3 to 6S BL-Heli32. It doesn't even end there. It even has a 10-volt regulator for $34. That's insane. Now, there are some compromises for adding the 10-volt regulator, so eventually we'll get to know how well these actually perform. Let's just scroll down, see what we can see. Obviously, it's going to be using the big FETs. We can see that right there. There's the 4-tier right there. This is the microcontroller unit, but there's that little logo right there. So you can see that that's bigger, so it's a bigger FET, which is really great. And let's just see here. we don't have more pictures, but I can see the filtration. Look at the filtration through the heatsink. That's really great. That's really good. That's something you always want. So this would be probably one of the all-time best budget ESCs. Well, we'll get to know that soon, but I do have high hopes for this ESC, and I am receiving a couple of them very soon, and I will definitely be noise testing these guys. So here's another example. This is a Mamba F35, and again, always take a note of the size. This is a 20x20 2 to 6S 35 amps. Now, this is the kind of ESC that I would recommend for just a normal load 5-inch setup, like a good 2300 kV motor or a 2400 kV motor. You should be fine. Even slightly bigger than that, you will be, but I don't recommend you push it any more than that. You can get away with it, but eventually it'll probably die out on you sooner or later. So yeah, it's $40, and it's a 20x20. And again, if you're looking for a high load 20x20, then this is the route you should go. I'll have it linked down below. This is an insane ESC right here. So here's another 30x30. This is the all-time best ESC ever, in my opinion. This thing is just out of this world. I mean, I've never been able to burn this no matter what I've done to it on the testing that I usually used to do. So this is like just crazy. So let's take actually a closer look at this. So it's a BL32 4 to 6S, and it's 65 amps, rated for 65 amps. So you're going to be good on voltage spikes. You're going to be good on a lot of things here. Let's go down and take a closer look at it. Now you see this copper rod right down the middle. This is to improve power delivery. This is to improve the current flow rushing through. Instead of just relying on the PCB itself, the PCB copper traces, they put that extra rod up there, and it just allows more electricity to pass through. And also another really nice feature is you see all the FETs on one side, which gives you better power delivery in theory. So that's really nice to see here. I know it doesn't look like the best execution, but this thing is an absolute beast. Look at the bottom side. This is just gorgeous. So this is running the latest microcontroller unit for ESCs, which is the F3, the fastest. Filtration looks pretty decent, really great actually. It's still at a low ESR capacitor, and it's just an absolute beauty. You can see the edge plating right there. You can see the copper on the edge. That's a more expensive manufacturing process, and it gives you more copper on the board. The more copper, the more power delivery you have, the less resistance, the less heat. That's how it works. And this is just a beautiful little beast. You have motors 1, 2, 3, 4. There we go, VBAT. So again, always make sure the output power of the ESCs, always just put it into consideration that all of them will output battery voltage. So when you get the flight controller, make sure it takes battery voltage as input, or else you'll fry the flight controller. Alright guys, and that's concluded for this video, guys. If you have any questions, I could revisit this in another video, so let me know down in the comment section. And also you can check the links down below. I have all this stuff linked down below along with some recommendations. And well, I'll see you guys in the next one. Peace out.